Now just with playing the trackbars, I can mask out this spiral notebook easily. Now as you can see, I have used the drag bars, adjusting them. I have created the background image on the foreground.
Hello everyone, welcome back to the channel. My name is Push. In this video, I have made a background remover like in Zoom using OpenCV. So how does this work? To find out, watch the video till the end.
Oh, hello, welcome guys. In this week, we are going to use the face detection. So first, I have created a function detect faces, then provided the path. So now I have used the pre-trained model of the hard cascade, which detects the face. Then I have converted the image from BGR to gray. Then I have created a variable called faces that contains the image, which is gray. Then the scale factor 1.1. So it tells the image to shrink 10% every time. So it can catch as many minute details in the image if it is a face. Then minimum neighbors equals to 5. So it tells that every time the cascade identify a face, it draw a rectangle over the face. So there needs to be minimum 5 rectangles over a face to identify it as a correct face. Then the minimum size is 30 pixels times 30 pixels. So the min size says that the minimum search must be 30 pixels across 30 pixels. Below that, it won't find a minute detail. Then I have printed the number of faces in the image. So the faces using the cascade formula gives the x, y, w, h variables. So x comma y is the top left corner, w is the width, and h is the height. So now you have to draw a blue color rectangle. So in order to draw, first I have getted the top left corner, then the bottom right corner. Then I have put a little text of face detected. Then just use the IamShow function to print the image. And let's now upload the image. So now I've uploaded an image. So let's run the function. So here's the face detected. So now the function works perfectly. So in this video, I will be creating a HSV masking using the webcam. So it is like the green screen effect, or also known as the masking effect. So first I have set up the track bars. As in the previous week, I have done changing the hue, saturation and the value using the track bars. So now I have added my IP webcam URL and then set up the track bars using the function. Now I have used a while true loop which captures each and every frame from the webcam. Next I have converted the BGR to HSV colors for fine tuning the image, then using the upper and the lower bounds to get the track values. Then I have used a morphological operation using the kernel which solves the issue of the choppy mask. Then I have used the bitwise AND operator to combine the images. Then calculating the FPS using the current time. I have first converted to the integer data type, then 1 divided by the current time minus the previous time. I have set the previous time to 0, then displaying the FPS and displaying the windows. Now let's run the function. Now just with playing the trackbars, I can mask out this spiral notebook easily. So on the previous day, I have masked the image using the green screen effect, and now what I'm going to do is smoothing the edges. For smoothing the edges, so first I shave off the color spill. So what is color spill? As the reflection was coming from the background, I removed the reflection and the pixels were either 100% onto the foreground or 100% onto the background. So it is not the case for the reality. Pixels must not have to be 100% foreground or background. They can have a mix of both. So I now smooth out the edges using the Gaussian blur and applied the alpha channel. Now let's run the code. Now as you can see, I have used the drag bars, adjusting them. I have created the background image on the foreground. So now I have created a class of the app that I have previously made of background remover and integrating all the functions that I have used, and at the end I have used this to integrate it in any function or project that I will make. Now I have pushed it to the GitHub and it is, as you can see, posted onto the GitHub as a week 3 folder.